Hello there, welcome back to more Haskell live coding. Plan for today is to go back to the front end of the compiler. At the moment I have a compiler that can parse basic numeric expressions, so like addition and multiplication and so on. And it generates, or at least it used to generate, some bytecodes I could feed into my VM, and it would evaluate these basic expressions. In the past few weeks, maybe a bit longer actually, I've been working on how to add functions to the VM part. So I've added opcodes for calling functions and returning from functions. And then finally last week for passing parameters into functions and functions that can call other functions. So that's all great, but now I want to go back to the front end and add functions to my basic language so I can have a simple calculator, but it can also use functions to define some calculations. So it's going to take me a little while, I think, to add that all to the compiler, but I need to start by parsing it, basically. So I need to design some syntax to express functions and then some kind of way of parsing it. I'm not very good at writing parsers, so this might be a bit painful. I'm not really sure what I want to emit from this. Like there'll be some kind of abstract syntax tree, but I'm not entirely sure what it's going to look like. But that's the plan for today. I might actually start with variables, because the other thing I added to my VM was the ability to define and then use variables. And parsing variables is a lot more straightforward, so maybe that'll let me get back into the parser in an easier way, I guess. Yeah, so maybe I'll start with that, and then if that goes well, maybe later today or maybe next week, I'll start to look at adding functions, which will be a bit more difficult again. Okay, so this is the code that I had for the parser previously. And it parses into this structure. So an expression is either just a number or it's addition, multiplication, or subtraction, not in order. And I think I must have had some tests for this. I did. Okay, well, there's parentheses as well. That's cool. So I'm checking that it spits out these tokens, I guess. So maybe I could just start trying to add variables. So I could say it parses variables. Let me just center that line. And then we can say calc parser. And then should parse. And what are we going to have? Oh, I need some input. So at this point, I'm going to need some input, and it should parse into p dot. Well, we'll just do a simple assignment. So it parses a variable assignment. So he says something like a is equal to 10. And say this should parse into p dot what does it parse into? It could parse into something like p dot identifier. Identifier of the literal a, but it's not. That's not really an expression, so it's probably going to be a sign. We can say p dot assign, and then it can have contain two elements, so it'll contain the identifier a and the value, I guess. So then it could be p dot int and the value 10. think that's what I want to end up with. I'm not sure I need this p identifier, but let's find out. Okay, so back to the parser, we need to add these in. I'm just wondering how it parses brackets, given I haven't defined them anywhere. They are here though. Oh, here my term is parens expression or integer, and the expression is, oh, I see, so it's operator table. No, not quite like expression. So the operator table, oh, it's this one, okay. So we say we have a binary operator, which is multiplication and plus. So I wonder if I could just add a binary operator that will bind lower than plus and minus and so on. So I could say we have a binary that's going to be equals, I guess. And the token for this can be a sign. I need to add a sign into my expressions. So then we can say, or a sign. So what are we going to have in an assignment? It's not two expressions, it's an identifier followed by some expression. So an identifier is a term, not an expression. So how do I define that? So where am I using p term? In here. So maybe we can just say that the identifier is actually just going to be some text for now. I couldn't match type text with expression. Expression, got text, expression. So maybe I do need to put something in here. And it's an identifier is something that contains text. No, see, that doesn't belong in there. That has to be expression. But we don't want the left-hand side to be an expression. We want it to be an identifier. So maybe this approach is not going to work out. Okay. Maybe this operator table is not what I want. It's make expression parser. That's something I'm search for. Make expression parser. What does it actually do? So build an expression table for term, which is first argument, I think, from this table. A table list of operator MA lists. That's what I have in my list operator. Monad? No. What's M here? Monad plus. Don't know what that means. So what have they got here? Term table, and their term is parent expression or an integer. Is parens optional here? I'm a little bit confused because I don't know how this works, I guess, but it's saying that term can either be an integer or it can be this parens of another expression. But you don't have to have parentheses. So how does this work then? Binary is a thing that I wrote or I copied. Okay, right. So binary takes some input text, and then I see. I think I see a little bit more. So it takes some input text. It takes a constructor basically, which takes two expressions and returns an expression. And it returns that expression lifted into the parser. And my assignment is not going to take two expressions. It's going to take the name of the identifier and then some expression, which is a value. Oops. So assignment takes the text as input. It then takes a function which goes text and expression and produces an expression. So text will be the name of the assignment. Whoops. And then it takes, it returns operator parser expression. So given some name and some function f, it's still going to be in fixel. Infix left, and then the function f now symbol. What is symbol? L dot symbol. So this is for parsing single symbol, I guess, because I'm passing into it like multiplication symbol, like star basically, or plus or minus. So maybe we don't need to pass in name here. Pass in the function, but we know what the function is, so we can just write this in. Okay, we know the function for this, so we could say this is infix left binding. Left binding? I don't know what the L stands for leftishness. And then the constructor for this is going to be a sign. And then is that assign apply to and symbol, but it doesn't have a name now because I know it's literally equals. Okay, so let's go back and add the sign again. I still think we should go from text to take text and an expression, but I don't think that's going to type check. No, it still expects it to be expression to expression to expression. Okay, so I'm not going to try and do it as part of pexpr. I'm going to give another possible term, which is going to be p_assign. I don't know why prefixing with p, probably just to know myself. So p_assign, oops, I've got type parser expr and p_assign is going to be right. So it's going to be an identifier followed by an expression. I think it's followed by an expression. And this whole lot is going to be lifted into the assignment that we have, the assignment constructor. Okay, so now we need to write the identifier. So p identifier is going to be a parser, but it's going to return text this time. It seems like the kind of thing to be a helper for, but we can say, what can we say here? Say something like many, oops, L dot, what have we got in here? Character literal, binary character, any kind of character. What lexeme is. The lexeme goes from parser to parser, so this isn't going to be what I want. Oops, have we got? No. Okay, what's character literal? Gives me something of type character. Look at text parser. That's character lexer and character. Is there like a text, make a parsec text? Yes, come on, no, there's not. Okay, so in megaparsec itself, we pulled in space 1. So can we do text megaparsec character? Has it got an alpha num? Alpha num character. Have we got an alpha character? What alphas do we have? Only alpha num character. Okay, let's go back to l.character literal. Oh, that's what I want. I want something of type parser text, I guess. Let me just see if I can find a pre-existing one. Parser text. Let me just take a look at megaparsec. What things we have? We have megaparsec character. Let's have a look at the lex so we can just check the documentation for the various things. Character and string literals. Character literal parses a single character without quotes. Escape sequences is not really what I'm interested in. Binary, octal, hex, scientific, float. It's all for parsing more complicated things. Okay, so if I go back to just character, then we should have something like letter character. So I'll grab this one, I think. Or I could even force it to be lower. I think. So we could parse a letter followed by some alphanumeric. So it was letter character. Yep. Byte, no. Add letter character to import listed megaparsec character. Cool. So this followed by some, I think, or was it, no, it's many. I can't remember what it was. Alpha num character. These one by one. So many comes from it's the import from megaparsec. Okay, and then we'd textify this. We can say t.pack. And data text is t. And it would be that. Okay, so t.pack goes from a string to text. Letter character gives me a character. Let's not be fancy, let's just try many of these things. Okay, kind of simple. So we're going to have many letters will form an identifier. Okay, so now we can say assignment takes some text and an expression. So go back to the test for this. We don't have p.identifier. So we can say this. So what are we actually returning? We're returning something of type. Oh, when is it kicked in? Oh, because I've added something. Right, let's ignore that for a second. So calc parser is going to return something of type expression. So here this p.sub comes from here. Okay, we're exporting everything in here, and we are importing it as p here. Okay, should be all right. So computer int 10 is a thing, and that's what the problem was. Okay, so we should get back an assignment, just goes from A to, assignment, yeah, assign A to the value 10. That's what I hope to get back. Yes, it won't compile because of this, so I'm going to say lower assign some name and then some value, and we can just say it's going to be actually I can say it's an empty list. So lower will be broken for this moment, but it should be enough to get it to compile. Oops. Try running the tests and let's see what happens. Seems to be running forever. It's not great. Let's stop that maybe. Can we stop it? We cannot. Chuck it away then. Okay. I'll just make sure that this is a problem. No, actually, I'll leave that in. I'll make sure that this is the problem. That's annoying. Let me just export PSI. I'm not going to use it. I'll just make it shut up for a second. Okay, let's go back to here. Hopefully it'll fail, but fail quickly. Yeah. Okay, so it doesn't know how to parse this thing. I should probably start by running the test, but anyway. Okay. So when I put in a term, is it this or an assignment? And then we have a problem here, I think. We could do something like L dot or even P integer. So we're not going to parse any type of expression. We're only going to parse accept integers for a second. Let's see if that will work, I guess, at least run. Oh, unexpected space. I forgot about spaces. Spaces are a nightmare. Okay, so it's going to be identifier followed by some space, potentially. In fact, I felt equal sign as well. That's coming from, I think. Okay, so there's a space 1. What's space 1 give me? I think that says at least one space, whereas let me look. space skips 0 more white space characters. Doesn't return them, it just skips them. Or H space is maybe even better. Yeah. So we won't skip new lines, but we will skip spaces. So it's going to be pid identifier, and then we don't want the input. And then we have an integer. No, we don't, though, do we? We have the literal. We have the literal character for equals. And I don't know how to specify literal character. Is it something like L dot character literal? That doesn't. That's going to return a character literal. It doesn't take its character to skip. Is there like a character? I'm not sure that my combinators are correct instantly. I hope they are, but I don't know that. So character, the character is going to be equals, and then potentially some space, and then an integer. I don't think that's going to work, but let's give it a go and see. Oh, it did work. Okay, that was unexpected. Can I put a bunch of these in place? So we could say identifier is, we could say 2. Might mess with the spaces a bit. I'll do it in a second. So we'll just check it can match multiple characters. And the value of this is 2. And then we'll do 1 without spaces. Then 1 without space on this side as well. Okay, just make sure those compile as well. Those work. Looks good. Okay, so that's all fine as long as we're assigning a single number to it. But that's not really what we wanted. So in one complicated case, oops. So we could say something like A is equal to, and then we could give it some kind of expression. So we say 1 plus 2. It should need to be in parentheses. So we can say 1 plus 2. And that should parse to p.sign. And my variable name is A, and my value is p.plus, of p.int 1 and p.int 2. Okay, and I think that will fail. Oh, interesting. Failed in a way I did not expect. So what happened is that plus is bound first. So it says the left-hand side of plus is the assignment of a equals 1, and the right-hand side is the value 2. So maybe we have a couple of things going on here. One is that the a equals 1, the assignment, is not an expression really in the way I'm designing it. It's a statement. It has side effects. It doesn't return a value. So maybe we could say something like data statement is equal to, and this is just going to be sign text expression, and I'll do this one, and I will export statement as well. And I can get rid of this PSI at the end. That was used to stop the compiler from complaining. Okay, so what happens next? So PSign is going to return a parser statement, not a parser expression. And then this will break because I can't have this as a P term. Maybe this is going to be problematic. Let me just check the type of make expression parser again. That, yeah. So it's saying for all M, type to type, M is Mona plus, what that means, but MA, and then the list of operators from M to A, and MA. So the type of this parser expression has to match this, which is parser expression. So I'm not sure make expression parser is going to be quite good enough. Okay. So here we said we're going to parse the expression and then the end of the file. But we could say it might not be expression, oops. It might be a statement. Probably define that. So just going to move these down a bit. So P statement which goes parser statement, and we can say P statement. Well, there's only one statement at the moment. We could actually just say it's P assign. Okay, and we're not going to return an expression. I can't say it's going to be an expression or it's going to be a statement. So can we say something like, I think it's going to mess up all my tests, but we can say program is, I don't know, like I kind of want to be a list now. This is going to be, no, let's just say it's a single thing. So it's either going to be an expression or a statement. So we can export this as well. And then down here, we can say we're going to return a program. And it's either going to be pxpr of this or p statement of this. So going to touch on that in the tests. Okay, so all the tests make no sense now. So this is going to be p.pexpr of that. p.p expr of that. p expr this thing. And p.p expr of this. And then we get to these ones. Okay. So let's go back. Okay, let's go to backtick, next backtick, and now it's serve these things. So here we can say p dot statement, and I don't know why. Oh, it's not statement, it's p statement. P statement. And then I'm going to wrap these in brackets, I think. Okay, and then I need to do the same thing down here. So it should parse p statement of that. Notes and show for p.p program. Okay, easily fixed. Hopefully, so you just need to derive show for both of these. Hey, Toma. Okay, so this is all good. I'm pretty sure that tests for lower will now be failing. Well, that can go for a start. If we have any tests for lower, they would call the parser and then pass the out from the parser into lower. So let's go and find that. Look, here it is. Okay. So lower is not going to take expression anymore. It's going to take, oh goodness. It's going to take a program. So many broken things. So if we're given p.expr of this, it's not p.expr, it's just expression. It's p.expr, sorry. And then p, oops, p expression of this. Oh, such a pain. And then p through this. Okay, and then hang on a second, it couldn't match expected type program with actual type. What? What's the actual type? Because the non-exhaustive makes perfect sense. I haven't added that yet. So p statement. And the only statement we have is p is sign. It's just a sign. And assignment has got 2 arguments that we don't care about right now. And we're just going to set this to be an empty list. Okay, now I can see where the error is. So if this is an expression, oh, it's going to be difficult. Where is this used? Is it just in a test or is it actually used somewhere? It's used in the parser, that's me defining it. And it's used in calc. Well, I missed most of the session. Okay. I can do a quick recap, I think. So, last time I got function calling and function returning and parameter passing and functions calling functions working in the VM, but they don't exist in my toy language. The language at the minute just does very simple mathematical expressions, so addition, multiplication, division. No, subtraction, not division. But anyway, it's a simple, it parses simple things like 1 plus 2 and 1 plus 2 times 3 and so on. So I want to go back and add function calling, function defining and function calling to my language. But I'm not very good at writing parsers, as you will probably see in a second. And I thought I'd ease into it by doing variable assignment, because that's another set of opcodes I added to my VM. So I'm trying to get it to the point where we can parse these things. And I got those working okay, but then I tried to parse this slightly more complicated thing where a is equal to and then some sub-expression. And that broke. It actually broke because plus was binding more tightly. So it ended up as being plus, and the left-hand side of plus, it said that the assignment a equals 1, and the right-hand side of the plus is 2. And it's not right, obviously, but it also, I think, is a little bit problematic because I was treating a plus 1 as just any other expression, and it's not an expression, I don't think. I think it's actually a statement because it doesn't yield a value, return a value. It has a side effect. It's setting something in memory. So what I'm now trying to do is split my parser, or the data structure I'm parsing into, from being just expressions like these things into being either an expression or a statement, where something like this is a statement. And then I hopefully get to the point where we say we have a statement where a is set to be this value. So I started doing that, and I created some new data structures. So I had this initially for expressions. Then I created a new data structure to hold statements, and the only statement I have at the minute is assignment. And then I created something called program, which is either an expression or a statement. And then what else did I do? So the parser for the assignment is saying match an identifier, which is just a bunch of letters, skip the space, match but don't consume, match but kind of ignore, skip over the literal equal sign, skip over some space, and then find an integer. Now I want to change this to p expression, but we can do that when I get the rest of it working. Then in my parser, I just said either parse an expression, which is what used to be, it used to be pexpert before, but now I'm saying it's either an expression or it's a statement, and that's okay. And then now our calc parser returns something type program. That required me to go and update all of these things with the data constructor for the program part at the beginning. And that's okay, but then we had this thing called lower. So what lower used to do was take an expression and it would turn it into some bytecode. Well, it's actually some intermediary tokens which eventually become bytecode. And this is used in my definition of a calculator previously. So we take some input, then we would run the parser on it, which would return previously an expression. Then we would lower it to a set of tokens. We lower it again from tokens into opcode, and then we run it using the VM. This is how the compiler used to work. Still, well, it doesn't work anymore because I've just broken it, but it's kind of a case of taking some input text, parsing it into some, I don't know, some tokens, I guess, and then just going through a series of steps to reduce those tokens to a lower level format. That's what it's doing at the moment. I'll have to make it more complicated for functions. Actually, maybe even for assignments, but certainly for functions. But this lower used to take an expression, now takes a program, and that's what's broken. And that's, I think, where you joined. So with that recap, I changed this function so that we match on program rather than matching on expression. And I thought I did it wrong, actually. I just naively thought, oh, we just match the program data constructor, and then we'll match the inner expression. But the problem is that this is recursive. So when it tries to lower the left-hand side of plus, this is an expression, but it's calling lower, which expects a program. So I think what I need to do is actually split this out and say lower expression, and this will take an expression. So this can be recursive. It takes an expression, oops, and returns some calc tokens. And then I can just copy these, drop into here, and say lower expression. And now I can get rid of this p expression. I'll get rid of that bracket. And then these can all be lower expression. Okay. And then up here, I can just say lowering of any expression E is equal to, and then we'll just call this lower expression, which it gives back the tokens. Okay, that's made the compiler happy again. It's not great. I mean, this should keep working for the previous tests I wrote for it, I think. So it should still parse expressions correctly, but it doesn't parse the whole program because this P statement just returns no tokens, so won't work. But the thing I'm interested in is it enough for these tests to pass and this one to fail in the correct way? So it should get upset about this plus. Three failures. Okay, this is the one I expected. He got upset about this plus. Parser rejection valid input expects to fail, but it actually succeeded. Okay, I need to look at that test. And calc key rejects invalid input. So there seems to be a thing where it's taking invalid input now. I think essentially the parser is going to check that the parser produces the right tokens, but calc key will work at a higher level of feeding an entire program, although that's not radically different, and just see whether or not it compiles, I think, what it's checking here. Okay, so let me fix these two first, and I'll go back and see if I can make this work. Okay, I'm going to try this one first. So line 24. So 1, 2, 3 ABC should not be a valid program. And what did it think it was? It thought it was the integer 1, 2, 3. Oh, this is where I start to hate things. Okay, so I think this is the bracket. Let's find out. So either it's an expression or it's a statement, and that whole thing should be followed by end of file. I think what I end up with is it should be an expression, or it should be a statement followed by an end of file, which means I could parse an expression without an end of file, which means that when I give it a partially valid string, it'll return just the expression part of it. I think that was what the problem was. Let's find out by running the test again. Good. Okay, now we're down to one failure, which is the one that I wanted, which is our complicated assignment doesn't work. So now we go to our definition of assignment. I said it's identifier, followed by space, followed by equals, followed by space, followed by an integer. But now I think I can just change this to expr. So it'll parse any of the previous expressions. So I would hope that anything that appears here can now also appear here. But let's find out. Look at that, it passed. Good stuff. Okay, and then one more, I guess, just make it as complicated as I can. Well, not as complicated as I can because it's arbitrarily complicated, but within reason. So we can say ABC, oops, is equal to, and then we can do something more complicated. So we can do some brackets. 1 plus 2, in fact, let's mess up the spacing here. Multiplied by 3. It just makes me angry, that spacing, but anyway. Should parse. Okay, it's going to be a P.P statement. And the only statement that we have is assignment. Text part of this is ABC, and the expression part of this is what? It's mult is the either one, and the left hand side of mult is the 1 plus 2, and the right hand side is the 3. Okay. So it's p.mult, and the left hand one is p.plus, and it's 1 and 2. So p.int end of 1. Oops, missed. Okay. And then this is p.int of 2, and the final expression is p.int of 3. That needed to be bracketed. Let's put it in the middle. Okay. So it should be an assignment. ABC is set to the multiplication of 1 plus 2 and 3. 1 plus 2 times 3. And it worked. Excellent. Cool. It should have worked. I shouldn't be surprised. All right then. So I'm going to stop at this point. Yeah, I'm slowly getting back into remembering how parsers work. I think maybe next week what I'll need to do, I can do two things. One is I can start looking at parsing functions. I also need to be able to look at parsing multi-line programs, because we say it's got to be one statement, so one expression. That's a statement. It's got to be one expression or one statement, and then the end of the program. So I should maybe make it parse multiple lines, so you can have setting up a variable and then using the variable in the next line. That could be quite good. And then I guess before I look at functions, what I might do is go back and look at lower, these multiple lowers. So I want to get from, you see, what it's currently doing is going from a bunch of tokens to a bunch of slightly different tokens to a bunch of opcodes. And what I will probably want to do is go from a bunch of tokens to an abstract syntax tree, and then take that syntax tree and turn it into a list of opcodes. It's probably the way I want to go. But I'll come back and look at that next week. But yeah, thanks for watching along, and hopefully see you again next week. Goodbye.